Hola, buenas tardes. Mio español está veramente troppo básico por hablarlo, entonces ho hecho un poco de español nella diapositivas y voy a hablar piano piano en inglés. I will try to convince you that not only climate has an impact into the ocean, but actually ocean is our climate. And this is why we needed to understand our Earth system evolution to improve our understanding, but this is also not only to improve our understanding and monitor how it is changing, but also to try to have the information to adapt to climate change. So here is just the mean anomaly of temperature, mean over the Earth, together with the concentration of CO2, that is the major greenhouse gases, that is increasing the energy, the internal energy in our climate system. So this is something that you have already seen, except that these are just observations. These are not what is coming in the next years, this is just what happened. So there has been a year 2016 that was pretty hot, and this is because there was El Niño, that you for sure you feel it here because you have your coast really in the tropics in the Pacific. Now, Benjamin said that the temperature, the sea surface temperature of the ocean is increasing less than the temperature over the continent. And this is the figure that shows it, where you see the red is the air temperature increase over the continent, and the blue line is the temperature increase over the ocean. So the ocean, you think, is not warming as fast as the continent. But it's not exactly true. So we are talking about temperature. Temperature is just an indicator of the energy at that level. What is actually climate change is a change of internal energy. Greenhouse gases are maintaining inside the system more energy, and this energy is going somewhere. So for example, you know that ice, so glaciers, sea ice, and also the polar ice are melting. And so you think some energy is going to the melting of this ice. But here is the figures that is from, must be this one? Yeah. This is the figure from the last report of the IPCC, the working group 1, so the statement, assessment. And you see different curve and different colors. So the ice is the white. Do you see a lot of white? No. So this is a time series or where the energy is gone in the system. So here are the years, and these are just observations, so from the past. And actually not much energy of this surplus of energy that is created by this greenhouse gases increase is gone into ice melting. There is a little bit on land. There is a little bit on the atmosphere, so small that you cannot even see. It is in violet. And the rest, the major amount of energy, is gone into the ocean, where it's blue. So it's gone in the upper ocean, upper 700 meters, and it is going also in the ocean at depth, that is the darker blue. And if you compute the change in energy, actually, you evaluate this change to more than 94% of the energy of this surplus generated by global warming is gone into the ocean. So the ocean, the whole water column is warming, is getting higher energy. And this has a strong impact on our climate. So this is just a change in temperature observed between the last 2 decades and the 2 decades before, so from the end of the 90s and 2017 compared to the 1990. And you see that the ocean is getting in the surface a little bit reddish everywhere. And this is the change in sea surface temperature, essentially. And when you go into the ocean, inside is this figure here. So this is depth. And for the moment, we are very good at measuring the temperature in the ocean in the upper 2,000 meter. I will explain why. So this is the upper 2,000 meter. And you see the color red is where is going the energy, yellow, orange, red. There is really very small parts in blue that are a little bit cooling. So the ocean at depth is warming. And so the amount of warming of the ocean is calculated in terms of energy, and this is energy is called the heat content of the ocean. So you multiply the temperature times the volume of the ocean, and you have this curve. And here you have the models from the past, the different models at different depths, and the observations. So you see that the models, the Earth system models that are used for the scenarios, what is the IPCC report, are really going very well compared to the observations. So this means that you can trust models for the future scenarios, except that you don't know what will be the decision of governments in terms of emissions. So this is why you have in the IPCC scenarios different curve. So this is the optimistic curve for the future, means the government decides to decline very much the greenhouse emissions, and this one is just business as usual. And these are not the scenario itself in terms of increase of greenhouse gases, it's the change in the energy of the ocean. So how much the ocean is heating. And if we do not do much, we will have a kind of walls here. So the heat in the ocean is going really up very much. And so what are the impact of this warming of the ocean? And I will try to resume quickly because something has been already said by Benjamin. And I will try then to explain what the oceanography and climate community is trying to do against, or to try to prepare for that. So here is the impact, and because we have an ocean that is warmer, and the ocean is the ocean that is warm in the atmosphere. If you feel a temperature here, in general, it's because you have advection of air from the ocean, and with this transport of air, you feel the temperature that has been set by the ocean. So the ocean gives heat to the atmosphere that set the temperature of the atmosphere, and it gives also water. So all the humidity you find in the atmosphere, with the exception probably for the Amazon basin, but in general is set by the ocean. The ocean gives heat and gives also humidity. And when you have an ocean that is warmer, this flux increase. So we are increasing, if it comes, this, I need to use this, maybe. Doesn't work. Stay on the same figures. It's gone too fast now. Okay. It's thinking maybe it's too big, my file. So what is increasing is this hydrological cycle. So, and the exchange of heat with the atmosphere and the exchange of humidity, when you evaporate the ocean, the water from the ocean to the atmosphere, this means also another quantity of heat. So we have an intensified cycle, hydrological cycle, and this is impacting a little bit everywhere on the Earth. And namely, for example, here nearby in the Caribbean, there is an increase in cyclonic and tropical storm activities. So there are not more storms, they are more intense, and they contain more water. So these are just an example. Then the ocean is also impacting. Maybe I take my computer. Okay. The ocean is also impacting the cryosphere, so the ice melting. There are glaciers. We don't know exactly yet if it is really the impact of the heating of the ocean that is melting the ice in the glacier, but for sure it is helping to melt the sea ice and the polar ice cap, because the polar ice cap goes into the ocean is warmer, they accelerate the amount of melting of this part of the ice that is in the water, and the ice caps start to flow faster towards the ocean. And of course, as Benjamin said, this has an impact of sea level rise because the ocean is warming, so it's occupying more space, and because it is ice melting. So this sea level rise is really increasing in rate, and this is important because I will show you it's not increasing everywhere at the same rate, but it is important to know that the sea level mean is different. So when you have now storms that push waters towards the land, this will go further away inland. Okay, so you have flooding, or you have salt water going to the land in the coast. So there are many impacts due to that. And another impact that was not told is that is changing also the ocean circulation. For that, we have much less observation. It's very difficult to observe the ocean in the interior, especially in terms of velocity. But I don't know if you know the Gulf Stream and the change in the Gulf Stream, if it stops or not, and the day after movie. So they are watching this kind of circulation that enter in the North Atlantic because they are afraid about a tipping point that can bring back a glacial, but actually it's not. I mean, maybe it is decreasing, and this is what we're trying to observe, but what we observe is much more complex than what is given by the model. And actually, the warming is pretty important, so probably more important than the heat reduction due to this stopping of this part of the Gulf Stream going to the Arctic. But nonetheless, this circulation and change of this circulation has other impact that are summarized on this rock in these figures, and that show that this circulation that is global has really impact over the land. And it is just what is called teleconnection. So the ocean and the atmosphere are dialoguing, discussing together all over, and a change in one side makes changes far away on the other side. So understanding how they function is really very important. And we're still far to have understood everything because the ocean is opaque, and we cannot really observe or understand well the ocean unless we go into the ocean and measure it. So another thing that Benjamin said, so I will go quickly, is changing the internal structure of the ocean. The ocean is becoming warmer in the upper layers, and more, especially in the low latitudes here in the tropics. This makes the input of important nutrients for life in the ocean less accessible for life. And also there is less oxygen because when the ocean is getting warmer, it contains less oxygen. And so this has an impact to all the trophic chains, so all what is the biosphere, primary production, mass of animal total, and also the fishery in terms of capture. And you see in green here are the observations, and the other two columns are the two scenarios. So it is already changing, not very much, and we start to have some observation. Biological observation are much more difficult to obtain, so we have less. But we have good indicator, and the change looks pretty big. So what is, I forgot to put a title here, but this is the last report that came out yesterday about the amount of global carbon that has been put into the atmosphere. And here is the scheme that show all the fluxes. So we burn carbon, CO2, we put in the atmosphere. Some part goes absorbed in the forest and in the biosphere on land, and this is why they are very important. And one part is also absorbed by the ocean. And this is why also the ocean is important. But still, the increase is pretty important, and we should try to make this curve, instead of increasing, going back into a decrease. So now we, I don't know, the goose came there, but I don't know why. Normally, what are doing the international community to try to understand, to better forecast and adapt a different scale. The scale of the weather, the scale of the subseasonal, so months, the seasonal, interannual, and decadal. Decadal is very important because if a major of a coastal city want to know if his town will be flooded or not, and needs to build a dam or perhaps move the city, it needs to have this really quantitative forecast. So we are trying to understand process, monitor climate change and the evolution of species, for example. And this are all the information. Also, we need to produce information that are useful for the end user, included government and territorials, policies and city major to try to take decisions. And in the atmosphere, we have a nice observing system that is sustained by governments, so the balloon, radio sounding, satellites, but most of the atmosphere lies over the ocean. And over the ocean, you don't have ships that regularly put radio sounding. And also, as I said, the ocean is really influencing the atmosphere and our climate, so we need also the observation in the atmosphere. So this is our observing systems, every dots. So we have satellites that measure different variables here, but satellites are able only to measure the ocean at the surface. To measure what is inside the ocean, included biology and chemistry, we need really to put zones inside the ocean. So usually this was done through oceanographic ships. Then we have started to put moorings, so fixed points that measure different parameters more and more in the modern days. And at the end, we have put autonomous system, and I will talk about that. So the important things to know is that satellites are really very important, but they are telling us just a partial part of our story and information of our climate system. So we need a really what we call in situ observation, so inside the ocean. So what we need to do? We need to go at sea. So oceanographic vessel and oceanographic observation from vessel are essential, and even if we now have automatic robotic observations, we always need these vessels. These cost money, but they are very important. This is the ground zero information, because all the robots have sensors that can deviate with time, so we need to calibrate all their values, and we need these ground zero observations. And so in the past, we had already some easy to implement observations for the temperature of the ocean, But they needed to be deployed by vessel, even commercial vessel. We had agreements. But these are all the observation of the ocean in 1 year at the end of the 90s. So these are the total amount. And they go only down to 700 meters. So you see that a huge fraction of the ocean was not observed. And this is why we implemented what is called the Profiling Argo Floats program. It's an international program. The United States are implementing half of it. Europe is doing a lot of the other part, but now China, India are coming in, and other countries. And this has been really a revolution in the ocean observing, because up to the Argo floats, all the observation from vessel or the oceanographic observation were properties of the scientific, the PI, the scientific leader of the cruise. So they were not sharing data. These data were mine, they're of my colleague, and we couldn't work to have a clear picture of the global oceans. With this program, we started to work, and all this data from the very first emission of data, I will explain how they work, the data are free for everybody. They are not owned by no one. And this data works like that. So these are buoys that have a sensor to measure, so the core program has a sensor that measures pressure, temperature, and salinity. And they have an antenna, here is this yellow one, that transmit the data when they are at the surface to satellites, and the satellites transmit data to the data center. These floats are deployed. They go down to 1,000 meters. They stay there for 10 days, and every 10 days they go down to 2,000 meters and make a profile, so observation up to the surface. They collect the data, they transmit the data to the satellite. They were staying at the surface for 8 hours. Now the new models stay just less than 1 hour. And then they go back to 1,000 meters. And this made really a big change. Since a few years, we are also implementing more sophisticated type of these floats that have different sensors that are measuring the chemistry, and some of them the fluorescence of the water. So we have an indication of how the chemistry is everywhere and how it is changing, and also how carbon is changing in the water, the amount of carbon, and how phytoplankton is changing. So they cost a little bit more, so they need more money, but they are really very efficient. So if we look now at the evolution of the observing system, so we had the ships with standard observing system like this one. This is the oceanographer rosette, where you have the sensors and you have bottles that you fill with water. And from this water that is collected at different depths, you can measure oxygen, carbon, and also all the species that are in the water, the small species. Of course, you don't catch fish over there. And then these are the pistols that were launching these XBTs, this first regular observing system that we had in the past. And now we have many more automatic observing systems. So we have the Argo floats. We have what are gliders, ocean gliders. So they navigate inside the ocean, going up and down. And when they go up, they transmit the data to the data center via satellite. Then we have also animals, and these animals are really very nice because they go in places where these Argo floats do not go, under ice. So we have now a great variety of data thanks to these animals. At the beginning, these zones that we put on the head were just to understand their behavior, but actually they are collecting also data for climate now. So if we look at these beautiful pictures, we say, well, the ocean now is really very well observed, but actually it's not. It's just 50% completed, and it's essentially just physics. We are still missing chemistry, and especially biology. So we need to work now. The international community is really working to try to address how to improve this observing system. And this is why, of course, for climate, weather forecast, to pollution, to help transport, so ship transport to be more efficient, etc. So there are different users. There is not just climate. And also coastal management and fisheries. So what is trying to do? The funding of this observation, whatever observation you have seen, is just scientists that are trying to fight to get this funding every year, or when they are lucky, every 5 years. So the funding comes always from the nations. It's not the international organization that give the money. So we need to rationalize this and try to convince our government to put the money in a common strategy, like it is for the weather. For the weather, you have a radio sounding of the atmosphere that are given at a regular, so they are paid by the government. So we need to try to do that, but we need also to improve the observing strategy, because we cannot measure every centimeter cube of the ocean. So we need to make the best of observation to answer the question we want to answer, and to put the observation where we need. And this is what is doing the international community since 10 years. So, for example, I was talking about the tropical Pacific observing system that started this collaboration, international collaboration, and was meant to have data to improve the forecast for El Niño. So they had to rework their strategy in a modern way, because now we have these Argo floats. Argo floats are most of these dots that you see in the ocean. And they have just produced their plans that is called the Tropical Pacific Observing System 2020. And I put here the website where you can download and look at. Then there are other two basins where we are trying to work. This is the Tropical Atlantic Observing System and the Indian Ocean Observing System. And for the Tropical Atlantic Observing System, for the moment, we are really open ocean. We do not touch the coast. We do not go into the Caribbean. So the idea now is to rationalize already what we can do in the open ocean, but to also extrapolate, to go towards the coast, from South America to Africa, and also into the Caribbean. Very nice. So Europe has been forcing us with a European project to produce very nice science. But actually this very nice science that we have produced helped us also to work in a very organized way together. So Europe actually is the first federation of states or ensemble of states that has organized an operational oceanography and operational climate weather systems. And these are European infrastructures. One for the ocean that observe the ocean is Eurogoose, that try to observe and give the strategy of the observing of the sea around Europe, and also give global forecast. And the global forecasts are done for the ocean by the Copernicus Marine System, that is CMMS here, where you can find actually the interpolation of the observation by models, and therefore you can try to have gridded data everywhere in the ocean. So if you look, you can have also data in the Caribbean Sea and the Gulf of Mexico that are model data every day. So Also, the oceanographer try to organize themselves through big conference that happen every 10 years. And this is the evolution between the first conference that happened at the end of the 90s towards the last one that happened this September. And you see the progress here of oceanography. So here there is, at the end of the 90s, the conclusion of a big experiment, a global experiment of ship cruises, where for the first time we sample all the ocean at least once in a kind of homogeneous way. And then we implemented, we said the ocean is more variable than what we thought. We need to catch this variability, so we need more observation, and we started the Argo program. And then we implemented more satellites. And we have now ocean forecast. And in the last year, we start to have also weather forecast made by an atmospheric model coupled to the ocean. And for this, we need data, and these data are precious. And we start also to observe the biosphere in a very different way, and I think my colleagues probably will talk about, but we go till the genetics now, even if it is more costful to take observation from that. And so the last OceanOps conference gathered 1,500 participants. And to prepare this conference, we asked the communities to write white papers. And these white papers need to be written to look at the next decade, what we want for the future, as observation because of our needs. And so you can download these papers. This is, I put here the links. They are open, free, you can read them. And there is, I think, one also on the Caribbean. And so you see these white papers were either on tropical Atlantic observing system or in the deep ocean, but you see that all of them are connecting with the others. So these clouds is just a connection of one paper with the other papers. So ocean science is really interconnected. It's connected to the forecast from weather to the scenarios, climate scenarios. It's connected with our life of everyday life. So now what happens to the community has gathered some recommendation and now try to put this recommendation into an action plan in order to try to solve some challenges for the next decade. So this is the action plan, and actually every community, Colombia included, can give their requirements, can try to participate. For example, if there are oceanographic cruises, they can upload the data to the international databases so that this data will enter in the forecast, and the forecast will be better. And also something that is happening starting from 2021 is the United Nations recognized the role of the ocean on Earth and decided to have a United Nations Decade of the Ocean. So the international community is trying to organize themselves to give the priorities for these decades. And in this moment, there are very many discussions, and every country give their priorities, and also these priorities are discussed at a high level, so at the UN level. And these priorities need to be within the Sustainable Development Goals. So the ocean has one, is SDG 14, but they are all linked together, and the ocean is linked to all of them. So this is what we are trying to process, and of course, every country has to put a strategy for that, and I think the mission of Savios is really trying to give an input also to this for your requirements. And so this is just how it works, and there will be a meeting for the North Atlantic starting of January. So you will, one of your person of your country, one oceanographer, is in the very executive committee. And so he will be speaking for Colombia. So there have been, I'm talking about Europe, because I'm European, but also because I grew up with Europe. I got my PhD funding to go from Italy to Paris by Europe. And I'm using European grant to do my research. And lately, Europe tried to influence also the policy and decided that the ocean is important. This was Carlos Meidas, one of the commissioners. So he tried to make other countries sign an agreement to work together, really, to put means in the observing of the Atlantic. So there have been 2 agreements. One is the Galway Agreement that happened in 2013 that involved Europe, Canada, and US. And another one that was the agreement, the Belém Agreement, that was signed in 2017, where Europe signed this agreement with Brazil and South Africa. Why these agreements are important? Because now Europe is putting calls for proposal that involve also the South Atlantic, involve southern countries. So the first proposal, we are, not me, but Europe is funding also colleagues from Brazil, Namibia, Angola, Cape Verde, Argentina, Uruguay. So, and this is something important. If this agreement was not signed, this would not have been possible. So, now I talked about what researchers do in an additional time to their research work. And actually, there is a lot of fundamental research that we need to implement still. There are many, many questions, even in the physical oceanography. So for example, we still need to understand how works this global ocean circulations. We have some observation in key places. Here, it is a map showing the trend of how the sea level is increasing, measured by satellite. So it shows that the sea level that we have been given in numbers is not homogeneous, is happening in a differential way in different parts of the ocean, and this is also due to the ocean circulation together with the rating of warming at the surface in different parts of the ocean. And also the ocean, I don't know if everyone can see these pictures there, but the ocean is not just slow currents that move compared to the wind. It is very turbulent, so there are a lot of vortex, a lot of eddies, filaments, and this dynamics is important for 2 things. First of all, because it shapes the biosphere. So all this dynamics brings foods to the first chain of the tropics, so phytoplankton, the phytoplankton then to zooplankton, zooplankton to fishes, small fishes, and then in. So it really influences the biosphere. And also influence the air-sea interaction. Air-sea interaction, so the ocean do not give heat everywhere in the same way to the atmosphere, but it's really linked to this dynamics. So we need, here for example, is a visualization of the energy exchange along the Gulf Stream. So it is just, this exchange is happening really very much along the Gulf Stream, not so much outside the Gulf Stream. So these scales are important to understand. We do not know them very much. We are not really very good in modeling them. We are not very good to model the other interaction with the atmosphere and the biosphere. So this is where fundamental research is important. And so there are many programs that, so this I show you if it comes, filaments and eddies here in the Arabian Sea, where you have a lot of phytoplankton. So the phytoplankton is not homogeneous. It goes in mushrooms and eddies, okay? And there are observations showing that this really impacts everything. So we need still to implement also our fundamental research to improve then our knowledge and the forecast. So I stop here. Thank you very much.